I'd like to introduce today's keynote, Mr. Dave Snowden. He is a former IBM fellow. He is one of the original thinkers that has influenced the Agile movement a lot. And I give you Mr. Dave Snowden.
Okay, I'll try and catch up on some of the time, but you may have to answer some of the questions yourselves over the dinner with a stranger, right? But we'll work on that. If at any stage somebody wants to challenge me or ask a question, feel free. I'll happily take those as we go. Can I just do a quick check? How many people are familiar with complexity theory? Okay, I'm going to take that under some advisement. We'll see where we are in a minute on that. Okay, we did a check on the Cynefin framework. How many people have actually taken our classes? No, just a couple. Okay, that gives me some idea. What I want to do today is to build some of the basic theory and apply it to contrast complexity thinking with design thinking. Generally, I'm making a wider point here that for the last 20 or 30 years, most management science and system design and everything else has been dominated by systems dynamics or systems thinking. And I do know there's a difference, but they kind of mean the same these days. The characteristic of most manifestations of systems thinking are to define a future state and try and close the gap. It doesn't matter whether you're dealing with what I fondly call Six Sigma, if anybody's come across Six Sigma. Business process re-engineering with the worst aspects of Bible Belt fundamentalism added onto it for good measure. The high priests of the cult get different coloured belts to indicate their cult status. And if you get a black one, you're exempt from doing any real work because your role is now to enforce cult discipline on people who are doing that. Either way, from that sort of approach, or Hammer, BPR, etc., Porter's 5 forces, strategy plans, 3-year plans, all that sort of cool stuff, says define a future state, close the gap. And most agile practitioners I know, if I'm perfectly honest, do exactly the same. They say, where do we want to be? How do we get there? Now I'm going to characterize that as idealism. At its most extreme, you see it with Peter Senge in Learning Organization, where the idea is we can define organizational values. And the basic idea, if you read Fifth Discipline, it said everybody should subsume individual values in the wider values of the organization as a whole. Thank God that's impossible. If it ever actually happened, it would destroy variety in the organization and give you 101 anthropology. The minute you write your values down, you just lost them. What you've actually done is to teach people the language of power. And from now on, every PowerPoint slide set and every business plan will incorporate those group of platitudes on your value statement. And there's only so many ways to say we'll be kind to customers and put users first, all right? So don't expect any originality in it. And basically, everybody will now just use those words. The reality is, and I'm going to come back to this later, but this is of vital importance in terms of requirements capture, we need to get underneath how people say they want to do things to how they actually work on a day-to-day basis. This is a difference between a rule-based culture where the rules are explicit, the values are explicit, and an ideation-based culture in which if you've grown up in the community, you know what to do, but you could never fully articulate it. Ideation communities trump rule-based cultures anytime. Not only that, if you try and enforce a set of values top-down, what will actually happen is the real values will go into the shadow community, the informal communities, and that's where the real work will go on. Yeah? So how this approach is because actually we've had for 20 or 30 years a domination of an engineering metaphor. And the assumption is the organization or the system is there to be designed. Engineers like to build bridges. Therefore, they want to know where the bridge is meant to start and where the bridge is meant to end. The last thing they want to question is whether you need to cross the river or whether there's another approach. What they want to do is to build a bridge and please give them clear objectives. And the engineering metaphor has really dominated management thinking. Complexity thinking, on the other hand, is deeply pragmatic, and I'm using that in the philosophical sense of the word, and I didn't for idealism, in case everybody's worried about that. And fundamentally in pragmatism, what matters is to describe the present, in the present to identify what you can change, out of the class of things that you can change, where can I monitor the impact of a change, and out of that subclass, where by success would I improve things, or by failure would I learn so I can improve things even more. So complexity thinking starts from the present and seeks to stimulate evolution, and therefore it uses biological and evolutionary models forward to a future state which couldn't be anticipated but is more sustainable. Now I want to argue that that basic theory is at the heart of the ideology behind Agile. The trouble is, Agile is practice heavy and theory light. It's a collection of good things that people have learned over time to do, but nobody's gone to the underlying theory behind it, and therefore we don't know how to scale it or make it work in different contexts. Which is why I want to start with this first slide, which has two key messages on it. One is the point is that human beings are actually important. For the last 20 or 30 years, we used computer metaphors of the human brain. We actually, in my daughter's A-level textbook, I withdrew her from the course. Said the basic assumption of psychology is that the human brain is a limited capacity information processing device. Now, when I read that, I realized it was probably true of the author of the book. But it's a fundamental error, because actually human beings are pattern-based intelligences. We have complex evolutionary reasons for the why we do things. We actually don't process things in the way that a computer does. But actually we've tended to assume that if you look at business process re-engineering, learning organization, balanced scorecard, all those sort of cool things, and then you can get into the pseudosciences like neuro-linguistic programming, which has been completely discredited by now. All of those things try and create a deterministic model which says if I do these things, I will get that result. Right? You're all familiar with that? Right, well, the big paradigm shift on this is human beings are human. Also, we're collectively intelligent. We pick up signals from, for example, pheromones over kilometers, which actually affect our impact or our judgment of validity or truth. Right? There's all sorts of complexities about human interactions with ourselves and our environment, which means we're not machines. Anything a computer is good at, a human being is bad at, and vice versa. And that should actually tell you something, right, in terms of the way we work. So this requires us now to take, and I'm going to introduce some core biological concepts as we go through, a co-evolutionary approach to software development, in which we allow users unarticulated needs. And I want to emphasize that because the things they tell you what they want are the things that they don't like in what they've currently got or that they've seen at the last software exhibition. You actually want to go behind that, and I'm going to talk about new methods for that, to the ideation, not the underneath reasons. And to allow those to coalesce with technology capabilities so that we get evolutionary possibilities that we couldn't have designed. In fact, I'm going to challenge the design paradigm with an evolutionary paradigm. No? And that's kind of like gives you a background to this. And really it comes with that phrase. I mean, as a former Catholic Marxist from the 1970s, all right, it's amazing the people you work with when you've got that background. One of the jokes we had in those days is we used to say praxis makes perfect. Now actually praxis is the interaction of theory with practice. So all the methods I've talked about, I'm going to talk about today, and the software we've developed, have been based on taking natural sciences, applying them in practice, see what works, see what doesn't work, modify the theory, practice again, a constant interaction between theory and practice. And our basic argument is if you don't understand why something worked, you can't scale it. And far too much practice, and I say it's generally in management, is, oh, it worked for those other 5 people, so it will work for me. Everybody familiar with this approach? Yeah. Every article in the Harvard Business Review, with an exception of a rather good one in November 2007, I wrote that one, in case you didn't realise, basically makes the assumption that I can study 10 companies, and if all those 10 companies are successful and they all have certain things in common, if I do those things, I will be successful. It's a confusion of correlation with causation, which is endemic in the social sciences. The fact that 10 successful companies have managing directors who play golf doesn't mean if your managing director plays golf, you too will be successful. It's equally true that the fact that 10 successful companies have 50% of their staff who have gone through Scrum Master training with a certain individual, it actually doesn't mean that if you go through that training, you too will be successful. Now, we need to be very careful of this because actually it's endemic in management science and agile type practice. The assumption is we can create recipes from previous practice. Right? So first and fundamental metaphor, the difference between a recipe book user and a chef. So a recipe book user, if you employ them to cook a meal for you, first of all, they re-engineer your kitchen. It has to match the environment they were trained for. Anybody wants to see any connection between this and the large consultancies, feel free. Having done that, all the ingredients will be arranged in the appropriate size bowls on the top of the counter, and then the recipe book will be prompted up and they'll follow the recipe, and provided nothing goes wrong, you'll get a reasonably competent meal. The chef, on the other hand, will come into your kitchen and they'll make a wonderful meal with whatever you happen to have lying around. And if something goes wrong, they'll adapt. And the reason is the chef actually understands praxis. They have what Aristotle calls Sophia and Phronesis. They have theoretical wisdom and practical wisdom. They've acquired their practical wisdom by an apprenticeship which has lasted years. And if you don't know it, it takes 2 to 3 years minimum for the human brain to actually physically reconstruct itself around any complex task. We don't learn from a book. We learn by a mixture of learning and doing, and the brain physically reconstructs itself. And the second thing is, they actually know about the theory of taste. And because they know the theory, if something changes or goes wrong, they can very quickly change things. Right? So if you think about it, at the moment we've been training recipe book users. And I remember going on one Scrum course to observe it, because we're about to produce a Scrum Cynefin training course. And actually at one point somebody said, just tell us what to do, don't tell us why. Now I find that quite appalling. But actually I've heard that from a whole bunch of people who've been through those sort of courses. What they want to be doing is just given a set of things they can go and do, because they want to follow a recipe, because of course then it's the recipe book author who's at fault if something goes wrong. Whereas if you're a chef, you have to take more responsibility for you and your team. Okay, now I've spent a bit of time on that because I really want to drive that point home. And therefore I want to give you a mixture of theory and practice as we go through. Okay, how many of you come across design thinking? Right, I have encountered this, and it was an interesting experience. Yeah, I'll come on to that in a minute. If you look at it, depending on how you look at it, I see there have been 3 primary authors, yeah, in terms of the way things work. You can go back to Herbert Simon, who actually starts to talk about the artificial. Design thinking really comes when we start to focus on artifacts, if you look at it in the literature. First real mention is Rowe in 1997, and then finally with Buchanan we get the concept of wicked problems. Now there's other books, there's other authors, there's other material on this, but those are kind of like my primary sources when I go into this. And it's become popular because there's lots of good case studies. You'll probably get some tomorrow because you've got Hideo speaking, of where gifted designers got together with users and produced completely novel solutions. Yeah, and that's kind of like what it's about. If you look at the basic principles, sorry about the transition, I just got into it the other day and I've got to break the habit, all right, but that's it. First of all, a lot of the literature says it focuses on solutions, not science. Now that starts for me to focus on red flags. Because what it does is it starts not to transfer method into people, but it creates dependency on the designer. And that was my experience of the 3 or 4 design workshops I've been through. That basically we were all put on tables to have ideas, and the designers went off to do brilliant things and bring them back to us tomorrow so we could appropriately worship their creativity. Yeah, and that was kind of like the way the workshops ran. And that was the big one for Microsoft. But fundamentally, the idea is we focus on solutions. That's fine in a way. A big difference is made in the literature between analytical thinking and synthesizing. So the idea is scientists break things down into small components, they analyze it, they try and work forward. The design concept is we synthesize concepts. Right, now actually I think that's a false dichotomy. You very rarely do one or the other, but that's one of the other key differences. And I'm building this now because at the end of this presentation I want to contrast pre-design thinking with design thinking with complexity thinking, and do that as a simple table, right, so we can see it. But that's a heavy emphasis on that. They talk about synthesis, they talk about analytics. If you look at a lot of literature, they say, well, it doesn't matter to get everything on the table first. What we need to do is to focus very quickly on producing something, and then if users like that, that's fine. If not, we'll produce something else, Yeah, now I can see the point of that. I can see cases where you do that. but it also means you may miss things because you move too quickly to a solution. Yeah, it's one of the dangers in complexity theory. It's called premature convergence. Moving too quickly to a solution, which means that I don't allow novel or interesting ideas to emerge. Yeah, but there again, you can see the design focus there. All of them end up with 3, 5, or 7 steps. I mean, this is kind of like, it's just the way it works. All right? I picked that one at random. Some of them put them in circles and imply it's not linear, but I noticed the arrows go all the way around the circle and come back to the start. So sorry guys, that's a linear process. All right? The minute you do something, before you do something else, before you do something else, even if you come back and review at the end, that's a linear process. Yeah? So the basic common approach, and this I've generated it, is you define the problem. I'm going to argue in a minute that's a mistake. Because actually the real problem may be something else, or the real opportunity may be elsewhere. Far too many statistical approaches and research approaches ignore outlier events. And actually outlier events is where real innovation happens, or real new thinking happens. So if you over-define the problem, the danger is you'll only find solutions to that problem, you won't find other things instead. Lovely British phrase called serendipity. Anybody come across that word? Comes from Walpole's story about the 2 princes of Serendip who were sent on expeditions to find things and never found what they were sent for, but found more interesting things instead. Right, and from that we get the word serendipity. Right, now I want to argue very strongly, in a modern software environment, most of the stuff where people know what they wanted has been done. The real value is to enable serendipitous discovery of technology capability which can augment human intelligence, and that requires a different design approach. And it's actually what's happening with apps and everything else. It's an evolutionary environment, not a design environment. Having done that, we prototype something, we implement it, we go and learn. There's a strong emphasis on visual metaphors. I want to support that. 2/3 of our brain is occupied with processing visual stimulus. So actually, one of the ways use of visualization is to allow people to connect and disconnect between different things. All right? So there's a lot of this stuff which has a lot of value. That I would support. And then there are some links to soft systems. Anybody in soft systems with Peter Checkland? Yeah, rich pictures. Okay. I go back on that. That's some of the best, to my mind, that's the best of systems thinking. It's the closest to complexity. Aside from that, I know Peter, he went to the same university, but the concept of rich pictures, because he's using strong visualization techniques to get people to see things in different ways. So the literature on soft systems is worth going to if you're interested in Agile full stop. And then finally, there are ideological aspects to this. As I said, one of my worries about this, and I sat through a workshop, and having gone through the workshop, that's what I thought. Because all we've done, I've done workshops loads of times, all right? And we all sat around tables, and this is one of the leading providers. I won't name them because it would get embarrassing tomorrow, right? But one of the leading providers, we're all sat around tables. Each of the tables has a facilitator from the organization which is running it. Yeah, they write down what we say, and several times I tried to correct them because they were writing down what they wanted me to say, not what I actually said. I got into trouble for that. Yeah. Other facilitators arrived to deal with me. It was quite a scary process, but it was fun. Right? And then at the end of it, having got all of this stuff together, they went away, and I've been part of the original design committee on this, and it was amazing how when they came back the next day, they came up with a solution that they'd actually told us was the likely solution the day before. And all our requirements had been repositioned and redesigned to match something they'd been working on in advance. Now, I know that's an extreme case, but that was one of the leading providers. But I've seen similar things 2 or 3 times. It really is dependent on the quality of the facilitator and their willingness to have their thinking disrupted. Now, interesting, if you ever work with advertising agencies, they lock the creatives up in a room and they don't let you see them. Because what they do is they feed problems into the creatives. The creatives come up with things and then they represent them to you. They don't let the creatives run the show, because the creatives already know what the solution is. I'm the creative, I know what the solution is, you will like it. So we need to think about how we use diverse resources in the way we work. And that's my worry on this, is it's fundamentally the designer is privileged over the user. And if you look at all of the cases are designers producing solutions after they've interviewed people. They're not about people themselves allowing solutions to emerge. Right? So we have a value for this, but we need to be careful about how we use it, which is why that cartoon from Gaping Void is slightly ambiguous. Okay, so what I want to talk about, naturalizing as a philosophical world, it means to base what you're doing in the natural sciences. My original degree is physics and philosophy as a joint major, and that gives me a philosopher's delight of concepts and a physicist's contempt for social science. And you'll see that come through extensively in the work here. Right? So what I want to do is take a naturalizing approach to this. I'm going to very briefly go through three things. I'm going to look at some new insights from evolutionary biology and neuroscience, but I want to be very careful here. I'm getting really fed up of going to Agile conferences and discovering people who've read one popular book on neuroscience, which is probably 20 years out of date. If it's really bad, it's Malcolm Gladwell's Blink, which is appalling if you know anything about the science. Yeah, and they're touting it as if it was an actual fact and would allow you to determine behaviour. Yeah, neuroscience is going through massive change at the moment. Anybody who makes definitive statements is making a fundamental error. We're learning more every week or every fortnight. We're getting some of the patterns out, but we need to be very careful. Because the one thing I know from the neuroscientists I'm talking to is none of it is creating predictive models. In fact, a lot of neuroscientists I know are now talking about the new phrenology. This is not meant nicely. It's basically people are mapping where the brain lights up, dependent on whether you do things. And then basically saying that means that part of the brain controls that sort of behaviour. Yeah, and that's kind of like, if you remember it, the old picture of the skull with different areas of the brain marked down. And it's actually not the way it works. The other ones who are dangerous are people like Dawkins and others, who I happily call the new Calvinists, because they're basically trying to argue that things are predetermined. Yeah, we have this. Once we understand that, we'll be able to predict the future. Now, there are reasons not to go into that. I don't want to spend too much time on this. I want to add a caution, because I've been very worried about the use of neuroscience for a lot of Agile events. It's kind of like people are seizing on it. I remember at the one in Helsinki recently, it was a real nightmare. Somebody just read one book, yeah, and actually a controversial book anyway, and was just putting it forward as if it was definitive truth. Yeah, that's bad science. So I then want to go into cognitive complexity. That's complexity science with cognitive science added onto it. Yeah, the basic proposition here is that human beings aren't ants. This is a controversial statement among mathematical modelers because they need human beings to be ants for their models to work, but regrettably it ain't like that, right? Yeah, we're far more complex. So the name of that is cognitive complexity, and I want to do the role of narrative, and having done that I can start to pull the things back together again. So rough summary of how I see design thinking, some of the issues, some of the science, then we'll start to apply it. Okay, one of the key biological concepts is exaptation rather than adaptation. This is one of a series of pictures from a website. I was in Bangkok recently doing some work on how do you create resilience in flood recovery. And somebody showed me a whole bunch of pictures of how people invented new ways of dealing with problems when the floods came. This is one of my favourites. You put your car in a plastic bag. It's actually quite a clever idea if you think about it. And actually these got propagated and made and distributed very quickly. So you just open up the bag, you drive your car in, you seal it, and you make sure it's in the garage, it's not going to float, or if it does float it will come back without too much damage, and it's still okay at the end of it. And there are some other pictures, you know, cats with empty water bottles in woolen vests strapped so that they would float. All right, and yeah, the website is worth looking at. It's hugely inventive because what people did is they took something designed for one purpose and used it for something completely different under conditions of stress. Now that's called exaptation, not adaptation. So in biology, adaptation is a trait develops for a specific reason. So a butterfly's wings become dark because the trees are dark because of pollution. And therefore they're more disguised. You're all familiar with that case? If there's any creationists here, I'm not making any apology whatsoever for I'm saying that. Right? Sorry, I present in the States a lot, and 57% of the US now believe that the world was created 6,000 years ago. It's deeply depressing. Right? So either way, that's adaptation. Exaptation is where a trait develops for one function and it gets used for something else by accident. So for example, in human language, The cerebellum handles fine motor control, and it was very developed in apes because it allowed our ancestors to pick seeds out of pods. So we developed the cerebellum, created the ability to do very fine motor control of fingers. That actually is the part of the brain which controls grammar, because it's fine manipulation of objects. And this is actually a major change. We're starting to realize that we create generic capabilities which gets used for another purpose, rather than things getting developed because of a specific need. So historically, it was always argued that the reason, fins on fish became limbs is because the early mudhoppers had to go across land with, drought, and therefore the fins became limbs. Now, I always found that difficult when I did paleontology, because they'd all die and therefore they wouldn't breed, so how would you ever get the exceptions, all right? The mudhoppers that stayed in the water. If you look at some pioneering work, this is relatively recent, this is 60s, 70s, discovered that actually fingers developed for the sea, in the sea, for specific purposes for actually swimming animals, and then that was reused when they went on the land. So on the one hand, you've got Dawkins, Pinker, and people like that who are arguing adaptation, causality, there's always a reason for things, that's why I call them the new Calvinists. On the other hand, you've got virtually everybody else who's actually saying what happens is we develop things, then we find different ways of using them. All right? And that actually allows us to create exaptive purpose. Now in technology, there's loads of examples. Brian Arthur's got a whole bunch in his book. So somebody once actually noticed when they were maintaining a radar machine that a chocolate bar melted in their pockets. Yeah, that gave us microwaves. Yeah? IBM created a technology by which if you dropped your ThinkPad, which was a reasonable thing to do given the operating system you were forced to use on it, then actually the heads would lift off the disk so it would recover. Apple used that to create a screen which, as you reorientated it, would change its position. Who made the most money? Right? Apple are supreme at exception. They actually don't invent things for purposes, they find interesting things and find new ways to use them. Yeah, exception is key, and my argument is this is one of the major changes on complexity-informed agile methods, is designing for exception rather than adapting against known needs. It's creating systems and processes which allow things to come together in radical and novel ways, which means we need to focus on the modularity of what we develop, because if you put things together too much, then they have non-capacity to accept. Anybody implemented SAP in their company? Yeah? Anybody tried to play as a small supplier 2 years after you've actually implemented it? Yeah, that's an example of chunking things too much. Yeah, if you look at the way the web works at the moment, my desktop is multiple apps and odd applications that I constantly change because I get bored with them. We actually spend more time on our computer screens these days than we do in our cars. Nobody expects us to all drive the same car, but corporates expect us to have the same desktop. Yeah, the reality is in a modern IT environment, you have lots of different things that you put together in different ways and you modify them and change them. So you've created a constant capacity to adapt quickly and accept. In fact, you focus on resilience, not robustness. One of those key phrases. Resilient systems assume failure and focus on fast recovery. Robustness tries to prevent failure, which means when failure happens, it's catastrophic. Yeah? The other advantage of croaking on systems which recover quickly is you exploit the new opportunities first. So exaption is a key concept from evolutionary biology. It says keep the modularity right, allow things to interact, put pressure on the system, and you'll get completely novel incremental changes. It's please don't confuse creativity with innovation. The minute somebody says they're going to run a creativity program to increase innovation, you know they don't understand the theory. Creativity is a symptom of innovation, not a cause. I do a lot of, and systems thinking generally confuses symptoms with causes. They observe characteristics, they assume that's the cause. It isn't. I do a lot of work in battlefield KM. I've yet to see anybody play with different coloured hats on the battlefield to have novel ideas, but I've seen an awful lot of innovation. Because you've got the preconditions for innovation: starvation, pressure, and perspective shift. It's actually what the original concept of time boxing was about. And I remember this when DSDM got started in a pub in Cheltenham, because I was one of the 3 people who did that many years ago. And actually, one of the focuses on time boxing was to increase the pressure on the team, so they found completely novel approaches. If you over-resource people, they just do the familiar things. If you remove resource, put time pressure on, then actually you get completely novel and different solutions emerging. So again, this is understanding the theory so we can modify the practice. Yeah? I mean, it's no coincidence that great artists starve in garrets and warfare produces more innovation than peace, because you've actually got those preconditions. Yet you're not comfortable. If you're comfortable, you don't innovate. Yeah, it's a very simple process. Okay, so that's one key concept I want to introduce. The next one is most organizations basically produce a simple dichotomy. It's either order or it's chaos. And incidentally, a huge amount of people confuse chaos theory with complexity theory, but I'll come to that in a minute. They're completely different things. So basically, the idea is we've got one choice or another, and this has been the driver behind things like business process re-engineering, Six Sigma, and all those sort of things. The assumption is we want order. The other problem, by the way, is that most management methods have actually come sideways from American manufacturing industry. So people develop things in American manufacturing, which is a specific culture, and manufacturing is a closed system. Then they try and take those methods intact and move them into a different culture. That's bad enough. But then move them into a service culture, which is actually an open system, not a closed system. So what you actually find is these things work very well when you've got a closed, defined, structured process, but they fail completely when the level of ambiguity and uncertainty goes up. If anybody doesn't know it and you're having a Six Sigma problem, i.e. it's been introduced, go and look at the case studies on 3M. 3M, having been an early adopter, abandoned it for all Balcour manufacturing because it was destroying their capacity to innovate. Right? The same was true of Prince 2 and all those other good things. Overstructure, forced structure, gives the appearance of order, but actually destroys the capacity to innovate and makes you highly vulnerable to change context. Right? Now, what I want to argue is actually there is more options than that, and that leads me into the Cynefin framework. Now, I'm going to go through this briefly. Most people are familiar with it, but I just want to get the theory right. Basically, there are multiple definitions of complexity. In fact, you could almost argue now that complexity has become a generic term for a whole range of theories, from those which are scientifically based to those which are just people writing a book about something they read in Wikipedia. I'm writing a review about that book at the moment, which I thoroughly enjoy. It's called Magpie 101. So either way, that's the review title, not the book, I hasten to add. So basically, I need to use a definition here, and the definition I'm going to use is the constraint-based definition of complexity. One, because I think it's the most useful, and also it's the easiest to explain to senior managers. Yeah? So it doesn't require you to know a whole bunch of science, it actually uses common language. So basically, I need to define two things. In a human system, we have systems and we have agents. Now, a system for me is any network which has coherence. If you want a visual metaphor for this, think about a spider's web in the morning after rain. You can still see the remnants of the structure. There are breaks in it. It's messy, but you can see the pattern. That's called messy coherence, by the way, which is a key design principle. If you create messy coherence, emergence, good things can happen. If you actually remove the mess, then actually nothing novel happens. Now, to illustrate that, I use this a lot. My study at home is currently just gone through an ordered phase. Now, I finally got the tax returns in 2 years later, and I'm still paying the bloody penalties, all right? There were books all over the floor. There were papers all over the floor. I got fed up 4 weeks ago, so I tidied it up. All the books are in alphabetical order. Everything is filed. There are new filing systems. There are new bookcases. The floor is clean for the first time. The desk has been polished. Everything is in the right place. When I left last week, it was starting to disintegrate already. So what actually happens is so I structure it, then it disintegrates over about a year, then I structure it, then it disintegrates. That's called messy coherence. If I kept the structure in place and enforced it, and it was a big problem with IT some years ago. Everybody was obsessed with taxonomy. And then the IT profession decided they would use a philosophical word they didn't understand called ontology, and they still don't understand it. but they really meant a different type of self-generative taxonomy. And the trouble is, taxonomy doesn't just rhyme with taxidermy, it produces the same effects. Yeah? So basically what I need is increase the constraint, relax the constraint, increase the constraint, relax the constraint. And that's the way we all live. And that's the way IT systems need to be designed. At the moment, even when people go through agile processes, they end up with a highly constrained end product. When actually what you need to do is design the architecture and the objects so that you can go through this balance of structure, destructure, as the context actually shifts. Yeah? So basically a system is a network with coherence. Coherence is a really important word. It's the whole new approach to evidence-based policy. Is not based on something being right, but on something being coherent enough to justify an experiment. And you can actually mathematically measure coherence if you get the right input data. We're doing work on that on government policy at the moment. And an agent is anything which acts within the system. Now it's important to realise that in human systems, agents can be myths, can be stories or myths. They're not just necessarily people. In fact, stories have more agency in human systems than people do. And just remember that, because actually the stories limit how you see the world. I go to the States a lot. In the US, basically the political spectrum is encompassed by the right-wing party in the UK. They just, they're left-wing. The Democrats is the left wing of our Conservative Party. They don't have anything like our Liberal Party, our Labour Party. They certainly don't have communists anymore, because they got rid of them, all right? And forget that on international socialism and Trotskyism. They don't even know what that is, all right? Now, there's no genetic difference between the British and the Americans. The difference is the entrained patterns of the stories, which means they simply don't see things which fall outside the patterns of the stories people are told as they grow up. Now, be careful on this, because companies have stories, design teams have stories. Stories act as agents in human systems. So that allows us to very quickly define three types of system: an ordered system, a chaotic system, and a complex system. In a co-ordered system, the level of system constraint is so high that behavior is predictable. In a chaotic system, the agents are completely free of constraints, so it's random, which means I can use statistics. A lot of people, by the way, who use the Cynefin framework in Agile try and use, but I'll come with this in a minute, try and assume that chaos is a domain. It isn't, it's a transitionary state. Anything which goes into chaos will pop out. Nothing ever lives there because you haven't got any constraint at all. But most people treat Cynefin as a categorization framework, when actually the very important stuff on Cynefin is moving things between the domains. But that's for another day. And basically, in a complex system, the system likely constrains agents, but the agents modify the system as they interact with it. So basically, the technical phrase for this, the other key biological concept, is coevolution. So as things interact with other things, patterns form from the interaction. Once the pattern is formed, you can't go back. Anybody who's old enough will remember the debates between Microsoft Windows and OS2. Anybody remember that? Yeah, I got a disciplinary warning for choosing Windows over OS2 for software development, because everybody told me IBM always won those battles. Yeah. Apple Mac, the original Apple Mac against the IBM PC. What's interesting is the worst technology always won.